Hello everybody. Today I am going to discuss the gauge particle, which is known as Higgs boson. We will see what is gauge particle and the discovery of gauge particle, both in theoretical as well as experimental. And at the end of this presentation, we can understand what is gauge particle and why it is so important to obtain the mass of the particle. These are my outline. My outline contains the news, sudden discovery a new particle, current status of theory of everything, the mass issue and the Higgs boson, hunting Higgs and finding it, and at last we will discuss conclusion. The news is that CERN declared that they found Higgs boson of mass 125 GeV in July 4, 2012. The current status of theory of everything is the standard model. And standard model mainly based on two interactions, that is electroweak interaction and quantum thermodynamics. This figure represents the particle content of standard model, contains the particle quark, leptons, gauge bosons, Higgs boson. These are the corresponding mass of quark and leptons. We can see that top quark is the heaviest among all quarks and tau leptons is heaviest among all leptons. And this is the mass of the force carrier. We can see that graviton is massless, gluon and photon are massless, but W plus minus and Z bosons have mass 80.4 and 91.2 respectively. The mass issue more precisely, all interactions in nature are created by imposing a symmetry. Means nature loves symmetry, and symmetry can be imposed by the local gauge invariance, and local gauge invariance can be maintained when the gauge bosons are massless. So no problem with electromagnetic and strong interaction because photon and gluon are massless, but a problem with weak interaction because W plus minus and Z bosons are very massive. So we have to find a way in which we can give the mass to the particle as well as we have to maintain the symmetry. So yes, there is a way to do it, and that is known as Higgs mechanism. So this is a scientist Peter Higgs. He gave the theory of Higgs mechanism. Now to understand the Higgs mechanism, we have to understand the spontaneous symmetry breaking. So this is a Lagrangian of complex scalar field, and this Lagrangian is invariant under U1 global gauge transformation, means phi prime transform e to the power I theta phi, where theta is a parameter of the transformation. We can say that the potential term of this Lagrangian is minus m square phi dagger phi plus lambda phi dagger phi whole square. To find its ground state, we have to derive the potential to first order derivative and equate it to 0. And by doing this, we find that ground state configuration phi 0 equal to 0. And we can say that ground state configuration have a symmetry as well as Lagrangian have a symmetry. So there is no chance of symmetry breaking. So we call it as exact symmetry. But when we change the sign of m square, before we have a minus sign, but here we have a plus sign. So when we change the sign of m square and look up into the ground state by taking potential like this, we can see the ground state have a continuous value because phi naught can be continuous, because alpha can be take any value from 0 to 2 pi, so that phi naught will be continuous. So we have a continuous configuration of ground state, but to write Lagrangian, we have to choose one point. So we choose the point square root of m square by 2 lambda and write the Lagrangian. By doing this, we lost the symmetry because we have a continuous symmetry, and out of which we choose one point to write the Lagrangian. So theory will be spontaneously broken. What is the advantage of this? Spontaneous symmetry breaking gives the massless mode, which is known as Goldstone theorem, and we can call it as Goldstone mode. Now we will see the spontaneous symmetry breaking of local gauge invariance. This is a Lagrangian of local gauge symmetry, and we are not going to detail discuss of this mathematical part, and rather I can focus on this pink colored Lagrangian. This Lagrangian have a look at this term. This have a term like mu and in the bracket e square b square. Initially we don't have a term like this in the sky color Lagrangian, but here we have a term like this. These terms represent that Lagrangian will be contain mass term and the photon will be massive. We do not say the photon will be massive, we say gauge boson is massive. So initially there is a no term, so Lagrangian will be massless, but here we have a mass term. So by spontaneous symmetry breaking, the Goldstone mode is replaced by the mass term, and this is known as Higgs mechanism. By the Higgs mechanism, we see that we can give mass to the particle. So it is the only way to give the mass up to the particle, or it is not. There is another way. We can answer this question at the last of the presentation, but focusing it to the Lagrangian, that Higgs mechanism is the way to give mass to the particle. So this is the importance of Higgs mechanism, that we can obtain the mass from the sacrification of Goldstone mode. There is a 4-sector of electroweak standard model, out of which we focus on the Higgs sector. This is a mathematical part, is not so much, I don't want to go so much detail in this mathematician. I want to focus on this Lagrangian. Here eta represents the Higgs field, and this term, this 2 lambda v square, this represents the mass term of the Higgs field, means mass of the Higgs boson. Here W plus W mu represent W bosons, and these terms represent G square B square by 4 represent the mass of the W boson, and this represents mass of Z bosons. Eta is the Higgs field, so eta and W plus, this represents the interaction between W boson and Higgs field. This represents interaction between Higgs field and W boson. This is a corresponding Feynman diagram that we obtained from this Lagrangian, and this is the mass term of W bosons, mass of the W boson, mass of Z boson, thus mass of Higgs boson, means mass of God particle. Here we can see that G square is the parameter of the standard model, and it can found only by the experimental method. So we have to go to the experiment to find exactly mass of the W and Z bosons as well as mass of the Higgs boson. So standard model contribute to the theory of the Higgs boson. So to summarize Higgs idea, so Higgs field prevails in all space. It interact with particle, give rise to their mass. Stronger will be the interaction, more will be the mass. So that's why W plus minus and Z bosons are very massive, because they strongly interact with the Higgs field. In field theory language, I can say that particles are actually produced out of field. When field excited, particles are produced out of that. So Higgs boson can be produced by the small excitation of Higgs field. Higgs boson has no charge, no spin, and obey Bose-Einstein statistics. And any number of Higgs particle can be piled up anywhere because it is boson. And we can learn about Bose-Einstein condensation. The nickname God particle is proposed by the Lederman in his book, but Higgs is displeased that this name might offend to people who are religious, but still God particle name is very famous. If Higgs theory is right or wrong, only experiment can decide. And so people set out to find Higgs. This is the journey of Higgs boson, but somehow they cannot detect Higgs boson before 2012 due to some major problem. And at last, the Large Hadron Collider CERN win the race to find Higgs boson. Some data about Large Hadron Collider. The present energy status, it operates on 2013 and that is 14 tera-electron volt. And Large Hadron Collider work on the principle that two beams of protons moving in opposite direction and collide, so that tremendous amount of energy will release and that can produce Higgs boson. This is the overall look of the Large Hadron Collider. You can see that it contains two detectors, Atlas and CMS, and along with ALICE and SPS. This is a stimulated event observed on the CMS, that two protons collide and Higgs boson produce and it decay to other particle. We will see how to find Higgs with this equipment. First we have to produce Higgs. Higgs cannot directly produce from protons because Higgs have a more mass than proton. Proton have mass 1 GeV, then Higgs have a mass 125 GeV. So we have to need tremendous amount of energy to produce protons. So produce Higgs boson. So Higgs boson can produce from the quarks. So far at the LHC they had 10 to the power 15 proton-proton collision and produce about 10 to the power 5 Higgs boson. Why they do it so? Because by accelerating proton to such a large amount of energy, we can produce the Higgs boson. After producing Higgs boson, we have to detect it. We cannot catch it, Higgs boson, by our hand because Higgs boson lives for 10 to the power 22 seconds and at most it can travel to the distance of 10 to the power minus 14 meters. So it will never reach to the detector. So Higgs must be identified from its decay product. But there is also decay product from other particle. Means not only due to proton-proton collisions only Higgs boson can produce, there will be other particles that can be produced, and Higgs boson is detected as a signal above background. This is a decay of Higgs. We can say that most probable decay is bottom and anti-bottom quarks. We can say and 21% of W plus minus and other decay product of Higgs. Higgs can be decay by the shown figure. I will discuss two decay mode of Higgs. Proton-proton by the gluon fusion process, they produce top quark. And top quark is easy to produce because it is massive and proton-proton collide with tremendous amount of energy. So most probable particle produces top quark, and top quark have a very short lifetime, so it decay to Higgs boson, and Higgs boson we produced, and Higgs boson again decay to top quark, which decays to 2 photons. So these 2 photons reach to detector and we detect it. Similarly, 4 lepton decay mode of Higgs boson. proton by the gluon fusion process produce top quark, and top quark produce Higgs boson, and Higgs boson decay to 2 Z boson, and Z bosons along interacting with Higgs boson decay to 4 leptons. So we produced 2 pair of lepton and antilepton. Conclusion is that last missing piece of standard model has been found. Higgs boson has been found. But still there is a many unanswered question in physics. Last answered question is, who needs Higgs boson? Everybody who is android. So can we say that our all mass is responsible due to Higgs boson? No, because the mass of the electron in our body is 23 gram. So whatever the remaining mass, and I can say that other example is mass of the proton, because 1% of mass of the proton is due to the Higgs boson. So whatever the remaining mass of the proton, the answer is quantum chromodynamics. In quantum chromodynamics, we have a energy fluctuations known as gluon fluctuations, and when quarks interacting with gluon fluctuations, then by Einstein E equal to mc square relations, most of the energy, quarks have a very tremendous amount of energy, so most have energy converted into mass due to interaction between quarks and gluon fluctuations. So most of the mass comes from this interaction between quarks and gluon fluctuations. But still Higgs boson is important, because the mass theory starts from this Higgs boson, and later we have an advanced theory known as quantum chromodynamics, and but the basis is the Higgs boson is responsible for mass, and due to Higgs boson we have a interaction between Higgs boson and electrons, Higgs boson and protons, Higgs boson and other W plus minus Z bosons, and we get their mass. So mass concept is started from these Higgs mechanisms, and we can see how much it important. So these are my references, and I hope this information will be helpful to you. Thank you.